Numerical series 2. Consider 1 kg of an ideal gas at 1 bar and 300 Kelvin contained in a rigid and perfectly insulated container. The specific heat of the gas at constant volume Cv is equal to 750 joule per kg per Kelvin. A stirrer performs 225 kJ of work on the gas. Assume that the container does not participate in the thermodynamic interaction. The final pressure of the gas will be dash bar. Let's solve this numerical. Let us first consider the container as per the question. So this is a container which consists of an ideal gas. This container is perfectly insulated from all the sides. It is given here. So this is the insulation which is provided from all the sides to the container. Now this container consists of an ideal gas having mass m equal to 1 kg. So this is the data which is given here. Let's discuss other data given here. So the data given here are, so next is pressure, that is initial pressure is 1 bar. So P1 equal to 1 bar, and temperature, initial temperature, that is given T1 equal to 300 Kelvin. Next is perfectly insulation is provided from all the sides to the container. It means there is no heat interaction between system and surrounding. So we can consider here Q equal to 0. Next is specific heat of the gas at constant volume, that is equal to 750 joule per kg per Kelvin. So Cv equal to 750 joule per kg per Kelvin. Next is a stirrer performs 225 kilojoule of work on the gas. So just remember, this is on the gas. It means work done on the gas. So let's say this is a stirrer which performs some work on this gas. So as work done on the system, so it means here we consider W equal to minus 225 kilojoule. So this negative sign is due to that work done on the system. Next, we have to find out the final pressure of the gas as per the question. So final pressure, let us consider to be P2 is final pressure of the gas. So now we have to find the relations by which we get the magnitude of P2. So as this is a case of ideal gas, let's consider the ideal gas equation. So ideal gas equation is PV equal to mRT. So here in this question, it is given that volume is constant, mass is within this volume is constant. So here we assume mass to be constant and R is a constant. So we can say by considering all these things, volume, mass and that R is specific gas constant or characteristics gas constant is a constant. By considering all these things, we can say that this pressure is proportional to temperature, or we can say this P by T is equal to a constant. So by using this relation, we are going to calculate the magnitude of P2. So it means here we can consider this relation as P1 T1 is equal to P2 by T2. So if we substitute the value of P1 here, T1 here and T2 here, we get the magnitude of P2. But this T2 is unknown to us. So if we get the magnitude of T2 here, we can calculate this P2. So first let us find out the magnitude of T2, which is unknown. So for this we use the first law of thermodynamics. So by first law of thermodynamics, we know that Q equal to del U plus W. So this value of Q is 0 and in place of del U we can substitute CV del T plus W is what? Minus 225 kilojoule. Now this CV, this del T is what? That is T2 minus T1 is equal to 225. Now substitute the value of CV and T1 here, and after solving this we get the magnitude of T2. Now CV is what? 750 kilojoule, 750 joule per kg Kelvin. But here W is given in kilojoule, so convert this joule into kilojoule. So after converting this joule into kilojoule, so this becomes 0.75 kilojoule per kg per Kelvin. So now substitute the value of CV as 0.75 here. So this is 0.75 into T2 minus T1 is what? 300 Kelvin equal to 225. Now solve this expression. We get the magnitude of T2 as 600 Kelvin. So this is the magnitude of T2. Now substitute the value of T2 in this expression. So that is P1 by T1 equal to P2 by T2. Now P1 is what? That is 1 bar. Here it is P1 is 1 bar. So 1 by T1 is 300. So this is T1 300 Kelvin. So this is 300 equal to P2. So this P2 we have to find out here, and T2 that now we have find out this. This is 600. So now solve this expression. We get P2 is equal to 2 bar. So this is the final answer what we need to calculate here. Right? So this is all about this numerical. Thank you.